So, good evening, everyone. Welcome to this session. Let's start the session quickly. So, today's mentorship session has been cancelled. Sorry for the inconvenience. The session recording will be sent you guys soon by YouTube link. So today we'll just have the student presentation session by Asthana. So you can start the session by introducing yourself.
Okay, so my name is Astha Singh and I'm an undergraduate student at University of Delhi, pursuing my bachelor's in physical science with chemistry. So basically, I'm a second year student who's passionate about astronomy, physics, and I used to write articles, poems. So the one I'm presenting with you, Terraforming Transformation, it's an article that's written by me. So the PPT is based on that.
That's good to know.
Okay, so my screen is visible.
Yeah,
Okay. So good evening, everyone. It's an honor to be here today about and talking about something that lies in intersection of science, imagination, and future of humanity. So terraforming, transformation, exoplanet, and engineering of new Earth. As our world faces growing challenges from climate change to resource scarcity, the question of whether humanity could one day find or even build a new Earth is no longer just a science fiction. It's an active area of science and exploration. So you must be thinking, or you may be knowing about what exoplanets are. So exoplanet, planet that in orbit around stars far beyond Earth, far beyond Sun. What we are finding is that a breathtaking diversity of world, from maybe rocky orbs to exoplanet that challenges our prior assumption about planets that can possibly exist. So let's begin by stepping beyond the familiar. So when we gaze up at night sky, we are not just looking at the stars. Basically, we are looking at the suns, many of which host their own planetary families. Some of this world orbit twin sun, creating shifting shadow unlike anything of Earth. So we may have heard the name of Proxima Centauri. It's a star that is around 4 light years away from our solar system, and Proxima Centauri b, that is an exoplanet. uh, it lies around the binary star system. So basically, it exists in three body problem. Other may have vast ocean, violent storms, or landscapes shaped by forces we can barely imagine. So, yet many exoplanets share fundamental traits with Earth: gravity, season, tectonics, making them prime candidate for exploration. And perhaps the most compelling question of all: could any of these planets host life or one day human civilization? So these are the questions that scientists are eager to find out. The research are being conducted every day, just to know and find, is there any planet that has similar characteristic like Earth, if we can find water or if human civilization can exist. Okay. Science of exoplanet discovery, methods, and milestone. The search of exoplanet is fairly young. In 1995, the first confirmed exoplanet, 51 Pegasi b, was discovered, revolutionized astronomy. Soon after, we found our nearest neighbor, Proxima Centauri b, only 4 light years away from us. So, in 1995, we first confirmed the existence of exoplanet by detecting 51 Pegasi b. Okay. And it was founded by Michel Mayer and Didier Queloz. And it was a total game changer. Suddenly, the idea of other worlds, maybe other life, don't seem so far-fetching. After which, scientists created advanced method and research pattern to search for this diverse exoplanet and maybe super Earth and ocean world. Now we are talking about the classification of exoplanet, and we are classifying them on the basis of their size and composition. Exoplanets come in astonishing diversity. Some are rocky and Earth-like, such as Proxima Centauri b. Other are super-Earths, much larger than our planet, or lava planet with molten surfaces. We have also found carbon planets, iron planets, massive gas giant, and even cotton candy or super puffs, and even ocean world like GJ1214b. So on the screen, you can see that this is the classification of exoplanet based on their size and composition. So we have terrestrial rocky planet, gas and ice giant, water dominant planet, under which these all subcategories come like Earth, like super Earth, lava planet, carbon, iron, gas giant, hot Jupiter, ice giant, super puff planets, helium planets, ocean world, and alongside are the example of these subcategories. Next is the classification of exoplanet based on atmosphere, orbit, and evolution. So the category for the division of on the basis of atmosphere, orbit, and evolution are based on atmospheric and surface condition, based on orbital characteristic, and based on evolution and history. And their subcategories are extreme temperature planets, close orbiting planets, far orbiting planets, exotic temperature planets, planets around exotic stars, stripped or remnant planets. An example of them are like lava planets, hot Jupiter, carbon planets, helium planets, lava planets, and rogue planet, pulsar planet. So these are the classification of exoplanet based on atmosphere, orbit, and evolution. Now, detection method and technologies for exoplanet. The first we have divided on like roadmap kind of thing. So first is transit method and radical method. Second is direct imaging. Third is micro lensing and astrometry. Fourth is future mission that can enhance detection, like the discoveries that will be going on. And next is exoplanet detection in global collaboration, like multiple organizations collaborating with each other in order to find this um, new exoplanet and their categories and study, like having a study of them even more clear way. And advanced detection method unlock new wonderful worlds full of potential. So, talking about transit method and radical velocity. So, this method basically determines size, mass, and density. For example, Kepler um, that used to work from 2009 to 2018, HARPS and Espresso by ESO. Direct imaging, it studies atmosphere like Hubble and James Webb telescope from NASA. Microlensing and astrometry. This find distant and rogue planets like OGLE and MOA. So, with the advancement of science and new machineries and AI technologies, There will be future missions that will enhance detection and amplify our knowledge about exoplanet and all the possibilities that it holds. So future missions like NASA's Nancy Grace Roman Space Telescope will improve exoplanet detection. Exoplanets research is a global effort with scientists, astronomers, and independent research institutions worldwide contributing to new discovery every year. The next topic is impact of discovery expanding cosmic understanding. So each discovery has reshaped how we see the universe. We now know that planets are common around other stars. Our solar system is not just unique. We have expanded our view of how planetary systems form, challenging old assumptions, and perhaps more importantly, these discoveries deepen our understanding of our place in the universe. So, with the expanding cosmic understanding, we are um able to study and grow our knowledge like planets are common around other stars. It is not our own solar system that is very explicit of the power of holding life, and not only Earth has a capacity of holding life, but other planet also. It just we have to explore it eventually and find uh, and have a deeper study about them. It expands diversity of planetary system, challenges what previous planet formation assumption we were holding, and reshape understanding of the of our position that we are holding in the universe. Impact of exoplanet discovery, the search for life. Exoplanet research focus on planet in the habitable zone where liquid water may exist. So when we are searching for exoplanets and like what and if life is habitable there or not. So we used to detect for water, like H2O, if water molecular exists there, then we can detect for yes, life can also exist. Next is discovery of Earth like planet fuels hope and curiosity. So, discovery of planet that are similar to Earth will boost in resources, mineral, and also hope and curiosity. Research drives the development of biosignature detection protocol. So we can also search for what are the biosignature of the planet, and all also carbon dating and all that we can conduct there. Each new exoplanet find bring us closer to answering the profound question, are we alone? So, as we used to discover every exoplanet and their classification and sub classification, we are closer in answering the profound question that was laid down very many years ago, like, are we alone? Now we're addressing cosmic mysteries. The first one is the Fermi paradox. Okay. The search of exoplanet isn't just about finding cool world. It's also about answering some of the biggest questions we have never asked. Like, where did we come from? Are we alone? And what's our place in this vast, amazing universe? So the paradox basically asks if the universe is so big and old, then where is everybody? Given the high probability of exoplanets, especially potentially habitable ones, we should have encouraged signs of alien civilization by now. So Fermi paradox asks a question, where is everybody? And it and it also interrogate us by asking if our solar system is so old, and if the universe is so old and big, then where is everybody? And we should have encountered sign of alien civilization by now. The next is zoo hypothesis. So the zoo hypothesis is Basically, it describes that maybe there are alien civilization around us. It's just that we can't see them, or we don't have that technology to understand their existence around us. So we are kind of inside a cage where, and they are like basically handling the algorithm. So this is a zoo hypothesis. Next is the great filter. This idea suggests that there's some kind of barrier that prevents most of life from reaching advanced stages. It could be anything from evolution of complex life to technological self-destruction. So the great filter talks about there's some high technology or some barrier that prevent most life from reaching the advanced stage, or what we call as the alien civilization. It could be anything from evolution of complex life to technological self-destruction. Then the next is rare Earth hypothesis. So it suggests that what if there's no other planet that is as favorable as our planet Earth, and that's why we are unable to detect as such planet till now. So the next is technological limitation. It's possible that our current technology isn't that advanced enough to detect alien civilization, or that they use form of communication we don't understand. So the technological barrier that may happen or is a limitation, like um, we don't have that advanced technology so that we can detect them, and maybe the source of communication we are using, they are not. So these are few cosmic mysteries that we have talked so far. Next, challenges of interstellar voyage. So few challenges that that is laid down for that prevent us from interstellar voyage are light year, that it is that the exoplanets are many light years away, energy barrier, time scale, multiple technical hurdles, logical challenges. So, talking about light years away. Um, so, there are exoplanets that are very far away from us, and the spacecraft that we are using does not foster the distance, does not foster the traveling to those planets. Next is energy barrier. Maybe we don't have that much energy so that we can reach to those planets. And next is time scale. So with the traveling of spacecraft to different exoplanet, and on their journey, there is a time scale gap that also affect our interstellar voyage, and multiple technical hurdle like we have talked about energy barrier, and also our technology not being that advanced. Next is logical challenges. So maybe we have not found a good technology or a good spacecraft that is that much advanced so that it could foster our interstellar voyage. So exoplanets are located very far away. Even the closest star system, Proxima Centauri b, is over 4 light years away from Earth. This means that even traveling at the speed of light, which is currently impossible, it would take years to reach. The sheer scale of interstellar space creation is enormous energy barrier. Um, Current spacecraft propulsion systems are far too slow for interstellar travel. Chemical rocket, even the most advanced, would take 10,000 of years to reach the nearest star. And About energy barrier, the acceleration of spacecraft to a significant fraction of speed of light would require an immense amount of energy far beyond our current capacities. Potential propulsion method like nuclear fusion or antimatter drives are still in theoretical stage. And developing efficient and powerful interstellar propulsion system is major hurdle. Concept like nuclear fusion rocket, ion drives, solar sail, antimatter drives, these are promising system. Still, there remain technological challenges. Also, apart from this, there is time and human factor like long duration space travel. So, when we are talking about long duration space travel and traveling to exoplanets, multi-generational voyage would be necessary for interstellar travel, posing significant psychology and sociological challenges. Next is the radial exposure. Astronaut would be exposed to harmful cosmic radiation for extended periods, posing serious health risks. Other one is technological reliability. Any craft sent on such a long journey would need to be incredibly reliable and redundant system and the ability to repair itself. So together, let's continue exploring the universe and bringing new world closer to reality. So the drive to visit exoplanet system from our intimate curiosity and the profound question that hold about life's existence beyond Earth, such journey promise to revolutionize our understanding of planetary system and potentially secure humans' long-term survival. Though immense challenges exist, scientists and engineers are steadily making progress. Exoplanet detection methods are refined and life support systems are under development. Success in this area, coupled with ambitious future mission and young minds, demonstrate our commitment to bringing the vast interstellar distance. The endeavor fuels innovation across multiple scientific disciplines, making the dream of reaching other world increasingly tangible. Thank you.
That's really a great session from Astha. Thanks a lot. It was wonderful. So just wanted to know,
Thank you.
so as you said, you have published the article, right?
Yes.
So if you don't mind, could you send the article over our group?
Okay, yes.
Yeah, that will be great because all the curious minds they can, read your article and then comment on it too. So yeah, that will be
Okay.
great. So
Yes,
all the
definitely. I'll share that.
participants, so to all the participants, thank you for joining, guys. So if you have any doubts, any questions you would want to ask to us, yeah, your platform is free right now. Or would you want to give feedback about the session? Pranav, Sheikh. Okay, so the session's recording will be, yeah, Sheikh, you can ask. Will you be asking any question? What about the do we want to explore exoplanets? What are your views on it? Asta, do you have an answer?
Okay, so yes. So Sheikh, you are asking, do we want to explore exoplanet? Yes, definitely. Scientists are working on it. They want to, they have the theories, they have the mechanism and theoretical concept with them. But what we lack is the perfect technology and communication system, along with multiple challenges that we face, like I've discussed, radiation exposure. So these are the challenges that are currently there, that um, like stop us from exoplanet and explore, like traveling to exoplanet. But yes, scientists are exploring about exoplanet, and since 1995, where they found the first exoplanet 51 Pegasus b, till that time, almost 18 categories and 18 type of 18 classification of exoplanets are there, and still counting. So yes, we do want to explore about.
So, like in near future, what do you think? Like, what type of technology should be put forward so that we can explore exoplanets? Like right now, we already have James Webb Telescope and things like that, so that we are able to find out the composition of the exoplanets and get to know like if they're in the habitable zone and if water is existing. Stuff like we are just connecting it to like Earth's perspectives, right? So, what are your views in that?
Okay, so can you repeat the question again?
So I was just saying, right now, like, what type of technology should be like? What do you think? Just curiosity. Should like what type of technology should be like created, which is feasible to, so that it will be easier for us to understand about the exoplanets. Like for example, right now we have telescopes like James Webb Telescope,
Yes,
and we are able to know if the planet is in the habitable zone,
yes.
and the composition of the planet, and we are connecting it to like the
Hmm.
Earth's perspective, right? Like the water is present or some carbon, something like that. So, what do you think should revolutionize?
So NASA is currently working on future mission. Like there are some detection method from where we are categorizing the exoplanet and finding water and carbon and all the minerals that we have found so far, like the methods I've discussed earlier. But the future mission that NASA is fostering is the Nancy Grace Roman Space Telescope that will improve our exoplanet detection and also research along with al- also it is a concept of global effort. If we are working and we are inclusive about the topic, so it will foster and increase the chance of us um, to find all this answer.
So I think Sheikh has put forward a question. Do we have any solutions for the problems or any theory which can work on? Maybe he wants you
Yes.
to create a theory. So
Okay. So, since you want to know the solution to the problem or any theory which can work. So, basically, we have technological and propulsion, like we lack that side. So, there are few theories that will foster our spacecraft to interstellar voyage, like the nuclear fusion rocket, the ion drives, solar sails, and antimatter drives. So these are four theories, or these four concepts that are laid down, but these are only till theory and paperwork. We are not yet practical about this system. So yes, scientists are working on them.
yeah, that's great. I think the problem is cost efficiency, right? Because like if you want to work on like advanced technology, then it's always the costs which people say, and then they go for the easier missions instead of the futuristic ones.
Yes, cost, and also is that if we are thinking to travel exoplanets, like if we are thinking to travel the nearest one, the Proxima Centauri B, it is 4 light years away. And if we are thinking to have the speed of light and reach there, it will still take many years for us to reach the nearest of the exoplanet. So it is still a theory and paperwork. Right now, we are not much practice.
Yeah, got it. Okay, then let's wrap up our session, guys. Again, thanks, Asta, for joining us and then giving a wonderful session. Again, you can drop down your article link in a group, and the session is recorded. So your PPT and the recording will be sent to in the WhatsApp group, and it will be uploaded in YouTube too. You will be receiving a certificate of appreciation for presenting at the end of the workshop. So thank you all for joining us. You guys can
Thank you
leave
so
the
much.
session. Yeah, you're welcome.